Hello. Today I'm going to go over arithmetic sequence and how do you find the number of terms in the sequence. Arithmetic sequence. An arithmetic sequence is a sequence that has the property that the difference between any two consecutive terms is a constant. This constant is called the common difference, D. So let's get started. Now, explicit formula for an arithmetic sequence. Given an arithmetic sequence with the first term a sub 1 as the first term and the common difference D, an explicit formula for the nth term of an arithmetic sequence will be given by a sub n, or the nth term, equals the first term adding to it n minus 1 d's. So it's like how many d's you need to add to a1. That's the main difference, or the main concept in arithmetic sequence. Now, just to get you started and understand arithmetic sequence, I just made a quick example. This is the formula. On top, a sub n equals a sub 1 plus d times 1 minus n. So it's not just times n, it's times n minus 1. Why is that? Well, here to go from 5 to 7, we are adding 2. From 7 to 9, we are adding 2. From 9 to 11, we are adding 2. From 11 to 13, we're adding 2. And from 13 to 15, we are adding 2. So the common difference is 2. And the first term is 5. But notice that we have how many terms? We have a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, a sub 6. We have 6 terms. Let's say we want to find the 6th term applying this formula. So with that, I do have a sub 6 equals a sub 1, which is 5. I'm referring to the formula on top, plus d, which is 2, multiplied by n minus 1. But in this case, I'm using n equals 6. So that's going to be the 6th term. So 6 minus 1 equals 5 plus 2 times 6 minus 1, which is 5. The reason why we have 5, because we are adding 5 2's. Here's 1. Here's 1, 2, 3, 4, 5. To get to the 6th term, you have to step 5 steps. 3, 4, 5. So let's double check. 5 plus 2 times 5, which is 10. And that should be 15. Okay, that's the main idea about arithmetic sequence. So it's all about starting at a sub 1 and knowing how many d's you want to add. Okay, let's move on. I have few examples, 4 examples. And here's number 1. Is each sequence below arithmetic? If so, find the common difference. Well, going from 1 to 2, we are adding, let's see if I have it separate. Yes, I do have it separate. From 1 to 2, we are adding 1. We're adding 1. Let me write beneath, I have more room. From 2 to 4, we are adding 2. From 4 to 8, we are adding 4. It's not fixed. It's not constant. So D is not available as a fixed difference. So the answer is each sequence below arithmetic? This one is no. Okay. Here's the second one. So from -3 to 1, we're adding 4. From 1 to 5, we are adding 4. From 5 to 9, we are adding 4. And from 9 to 13, we are adding 4. So D is available. It's a fixed common difference as a common difference. And that will give me D, which is 4. So the answer to this question is yes. Example number 2. Write the first 5 terms of the arithmetic sequence given. Since they called it arithmetic, so we do have a common difference, which is given to me as -3. We're starting with 17, and we need the first 5 terms. So here's the second one, here's the third one, here's the fourth one, and here's the fifth one. So we are counting 5 terms. Well, D is -3, so we are adding 1D here. 1D, that means we are adding -3, so we're going to go to 14. 14, add another -3, that will go to down to 11. Add -3, in other words, subtract 3, that will be 8. Adding -3 one more time, that's going to be 5. Done. Just to give you the concept of what is arithmetic sequence. Example number 3. I do have 2 parts here. Let's see if I separated them. No, I did not. So I'll just keep it right here. For each of the finite arithmetic sequence below, write an explicit formula for the sequence, then find the number of terms in the sequence. So, for the first one, we are trying to write the explicit formula, okay, and then find the number of terms, which is n. For part A, let me do part A right here, and I'll do part B on the right side. We have a sub n equals a sub 1 plus d multiplied by n minus 1. And here we have a sub 1 is 8, so that we're going to write 8. A sub n, which is the last term, will be replaced excuse me, by minus 41 plus d. What's the difference d? Going from 8 to 1, we're going down by 7. Double check, yes. So d is -7. To get to the last term, let's say it's the 17th term or the 22nd term, we need to know n. That gave me minus 41. So d is -7. I'll put it inside parentheses. Multiplied by n minus 1, we're going to solve for n. So we have minus 41 equals 8. Distributive property here will give me minus 7n. Minus 7 times -1, which is plus 7. We're going to add 7 and 8 on the right side. That gives me 15. Let's keep this right there. And minus 41. Subtract 15 from both sides, and I get on the left side we have -56, and on the right side minus 7n. Now divide both sides by -7, so n equals -56 by -7, which is 8. So the formula is right there. A sub n equals a sub sub 1, which is 8, plus d multiplied by n minus 1. And to find the number of terms, that is 8. Now, Part B. To go to part B, trying to make it fit right here on the screen. Here's part B. Let's erase that, and maybe I'll pick a different color for now. So part B, we have a sub 1 is 6, as you could see, and the last term is 101. So a sub n equals a sub n equals a sub 1 plus d multiplied by n minus 1. 101 will equal to 6 for a sub 1 plus d. Let's find d. Going from 6 to 11, we are adding 5. Double check from 11 to 16. Yes, we are adding 5. So we have d equals 5 times n minus 1. Let's solve for n. Using the distributive property, again, 5 times n is 5n. 5 times 1 is 5 with a minus sign. That's a minus 5. 101 equals 6. 6 and minus 5 will change it to 1 plus 5n. Subtract 1 from both sides. I get on the left side 100. On the right side only 5n. Doing the math, dividing by 5, so n equals 20. So the formula is a sub n equals a sub 1, which is 6, plus d, which is 5, times n minus 1. And the number of terms for this given arithmetic sequence is 20. Okay. The last example. Find the number of terms in the sequence. Now, I've seen students say list them all and they try to find them. You could do that, but of course, that's not what the problem is asking. Imagine if the last number is not 388. It's like 1,000 something. I don't think you want to list them all. So the proper way to do it is using the arithmetic sequence formula and finishing it. So we have a sub 1, a sub n equals a sub 1 plus d multiplied by n minus 1. And a sub 1 is negative 4. We could see that right there. Going from negative 4 to 3, we're adding 7. From 3 to 10, we are adding also 7. From 10 to 17, we are adding 7. So d is 7. So we're going to write that here. And n minus 1. A sub n will be the last term in this case to find the number of terms. So we're going to write 388, as you could see from here. Doing the math, I have 388 equals negative 4 plus 7n using distributive property minus 7. We're going to add the negative 4 and the negative 7 on the right hand side, which is negative 11. So we have 388 equals negative 11 plus 7n. Let's add 11 to both sides, and that's easy to add right here. 8 and 1 will give me 9 and another 9. So we have 399 equals 7n. Now we have 399 equals 7n. Divide both sides by 7 and you get this cancels, and n equals 399 by 7, which is 57. 57. That's the answer. So my point is, you don't want to list 57 terms and start counting them one by one to end up knowing the answer, which is 57 terms for n. The right way is use the formula and finish it, because you don't want to be given, let's say, instead of 388, a number over 1,000. So you don't want to list them all. The right way is use the formula, represent the last term a sub n with the last number, in this case 388, and do some algebra steps and finish it. That should do it. Thank you.